For the example 4, again, we have 3 items. So now we're going to begin with the first step. We're going to do the completing the square. So now let's do the completing the square for the denominator. So we have this one. Okay, so your coefficients of the x now is plus 2. So you will have plus 2 over 2 square minus 2 over 2 square plus 2. And the first that we have the x, okay, 2 over 2 will give you 1. So we have plus 1, and then we have square here. Okay, at the back we have 2 over 2 is 1, 1 square is minus 1 plus 2, that is give you a positive 1, right? So now that is our completing the square. Okay, so now let's just write the answer for the next slide. So we will have the x over 1 plus x squared plus 1. Now, after we have completed the first step, completing the square, we go for the substitutions. Okay, how to do the substitution? That is very simple. So we're going to do, you're going to sub whatever that is inside the bracket as the u. So we have the u as x plus 1. So in here you have your du, and this is actually your dx. Okay, so but apparently we have another x at the top. Okay, at the numerator. So what we can do is we have to manipulate this one, and this actually give you u minus 1 equal to x. So at the top, this one you have to change it to u minus 1. So at the top, so you will have this one as u minus 1. At the bottom, that what we have here is we will have this one as u square. Let me see another color is better. Okay. So we have this one as u, and we have this square here, plus 1, and this is our dx. Now, we are already in this form, right? Okay, when you're already in this form, I'm sorry, this is supposed to be du. So because we have to change this one, so this is actually your du. Okay, so we are already in this form. Okay, when you're already in this form, so you can see that apparently we have two integrations that we can use. Okay, so the first that is you will have the answer in terms of the logarithm, and one is the answer in terms of the tangent inverse. So means that you have to separate, you have to change the integrations, and you have to separate it into two, the integration itself. So you have to separate it. So when we separate it, so the first one will give you u over u squared plus 1 du. The second will give you 1 over u squared plus 1 du. Right? Okay. Now, let's just look at them one by one, right? Look at the first one. The first one says we have the first integration is actually in terms of this one, right? So you have u over u squared plus a squared, u squared plus a squared. So it means that you're going to apply this logarithm. Your answer should be in terms of logarithm. So you can apply the f prime over f. So if you want to apply f prime over f, if your f is u squared, okay, what happens to f prime? Your f is u squared. Your f is u squared plus 1. So it means that your f prime is supposed to be 2u, right? But what we have here is we only have u. We do not have the number 2. So what we can do to make sure that we can use this formula. So it means that you have to do some manipulations so that you can use the formula. So you need the number 2 at the numerator part. So it means that you have to multiply with 2. So we multiply with 2. But we don't want to change the question. What we have to do is you multiply with another number in front of that is 1 over 2. So 1 over 2 multiplied with 2, we will have 1. So basically, we do not change the questions. And by doing that, this is actually this is actually f, and this is actually your f prime. right? Okay, how about the next line? The next line, you can leave it that first, okay? So we leave it that first, okay? Okay, so this 1/2, the first integrations is basically in terms of this. So you will have the integration of f prime over f, okay? So it will give you ln f. So your answer you will have in terms of ln. What is your f here? Your f is u squared plus 1, right? So that is the first integration, the answer for the first integration. How about the second integration? If we look at the second integrations, we are supposed to use this part. So you will have 1 at the top, okay? So your answer will be in terms of tangent inverse. So if you look at this, line, so we're supposed to have the a square here. So in order to have a square, okay, so your 1 is actually equals to 1 square, right? We have 1 square. So you have a is equal to 1, okay? So means that you can apply this formula. Then when you apply this formula, you will have 1 over a. Your a is 1. Then you have tangent inverse, and then you have x over a. Your answer is supposed to be in terms of u because you are integrate with respect to u. So you have u over 1, and then you have plus c, right? Okay, and let's simplify the line. And you simplify it, and this actually give you tangent inverse u plus c. But as I said just now, okay, in the previous example, we don't leave our answer in terms of u because you are doing with x, okay? So you will have to change it back to the x, okay? So let's just find back where is our x, okay? So just now we have substituted the u with x squared plus 1, right? So change it back, okay? So your answer is supposed to be in terms of x. So you have 1/2 ln. The u here is actually x plus 1 squared plus 1 and minus tangent inverse. Okay, the u is x plus 1. Right. Okay, what is inside the ln? That is, you can expand it. Okay, if you expand it, we have x squared plus 2x plus 1 and plus 1 again. So then, okay, let's simplify some more. So we have 1/2 ln x squared plus 2x plus 2. Right, okay. So this is the answer for this example. Okay, for example 5, okay, let's just do the converting the square. So this is actually give you x squared plus 2x plus 4, and your coefficients of x is actually positive 2. So we have plus 2/2 square minus 2/2 square plus 4, and the front we will have x plus 1 square. At the back we have minus 1 plus 4. That is actually give you positive 3. So that means that your next line of integrations, your denominator going to change it to x squared plus 1 squared plus 3 dx. Okay, so this is the first step. Next step is we're going to do the substitution. So let's just sub the x as the u plus 1. So in here you have the u that is actually equal to the x, but you see that we have x in here, so means that you also have to do the substitution for this x, okay? So another it means that you will have another line here that you have the u minus 1 is actually equal to the x, okay? So you're going to change this one as u minus 1. Okay, so the next line I will have 2, okay, and the x we have to change to u minus 1, so you have u minus 1 here, and we have the plus 5. So this is the plus 5, And down here we have x plus 1, x plus 1 is u, so we have u, and we have the square here, so we have square plus 3, and the dx is actually the term of du. Okay, it seems it looks like complicated, but actually it's not. Let us simplify whatever at the numerator. So we will have 2u, and we have minus 2 plus 5, okay, and then it's actually u squared plus 3 du. But instead of before we go to the next line, let's just simplify some more on this step. So if you simplify some more, so we have 2u plus 3, and you have u squared plus 3 du. Now we have done with the substitution. We already go in this general form. So in this general form, it says that you have to separate into two different integrations. So the first integration, so we have to take out the value of 2. So we have the 2, so you have the u over u squared plus 3 du. The second is you're going to take out the number 3, so we have a 3, and you have 1 over u squared plus 3 du. Apparently I have skipped some stuff, but I hope that you already understand how I get that. Okay, so let's just go for the integration part. Okay, if you look at the integration part, okay, the first integration is basically your answer will in terms of the logarithm. So you're going to use the f prime over f, and you have this one as the f, and what is your f prime? So your f prime is 2u, right? So we have the f is u squared plus 3, so your f prime is supposed to be 2u. Okay, so means that we need the number 2. Okay, I already have the number 2 here. So what I can do is just erase these two, which is at the front. So I put it back. So I have my f prime here. So I have my f prime here. Okay, so I can use the formula directly, and I know that this actually ends with ln u squared plus 3. Okay, now let's just look at the second integration. The second integration, we're going to have the answer in terms of tangent inverse. So it means that you have to think of the a square. We have the form of a square here. You have to have the form of a square here, because we want to use that formula. Okay, so what is our a square? So our a square is actually sec3 squared, right? Then you change the 3 to sec3 squares, and you can use the formula. So we have ln u squared plus 3, and now you will have the answer that is 1 over sec3, and tangent inverse this is in terms of u over sec3 plus c. Okay, simplify it some more. Okay, let me prove that out. Okay, we already use this formula. Your answer is in terms of the tangent inverse. Let's simplify it some more. Okay, so ln u squared plus 3, and this is 3 over sec3, tangent inverse, this is u over sec3 plus c. And don't leave your answer in terms of u, you have to change it back. Okay, what is our u just now? We said our u is x plus 1, so let's substitute back. So we substitute back, so we will have ln x plus 1, yeah, u is x plus 1, tangent inverse x squared plus 1 over sec3 plus c. Okay, for the ln, we can expand it. Okay, so we have x squared plus 2x plus 1 plus 3, and this one will be the same. This x squared plus 1, x plus 1 over 3 plus c. And then so we have the answer of x squared plus 2x plus 4. Yep, we are done with this example. Okay.